Hi guys, welcome back to my channel. Let's start today's topic. I've already taught you hydrogen bonding and the definition of the bonding, and we have done past paper question based on the hydrogen bonding. Yeah, let's do the consequences of the hydrogen bonding. If the molecule has hydrogen bonding, that that hydrogen bonding change the chemical and physical properties of that compound. Let's see. So chemical properties would not affect by the presence of hydrogen bonding, but physical properties are affected by the hydrogen bonding. Let's see. So look at the uh, look at ammonia NH3, and we have pH 3, and we have ASH3, arsine, phosphine, stibine as BH3, and BiH3. All these are called hydrides of group 5 elements. Because of the presence of the hydrogen bonding in ammonia, it is highly soluble in water. Highly soluble. Highly soluble. Highly soluble in highly soluble in H2. And ammonia is polar. One of the reasons, but we are not looking the polarity of the molecule, but presence of hydrogen bonding make the ammonia molecule more soluble. Now these are called the hydrides of group 5 element, and we have hydrides of group 6 element, H2O, H2S, hydrogen sulfide, H2SE, hydrogen sulfide telluride, hydrogen perluride. Same thing. Water has high boiling point, roughly 100 degrees, and when you compare this, the boiling point is increases, but the boiling point is very low in case of H2S, then it increases. The reason behind this, it's large size. But why the water has high boiling point, more than 100 degrees? Because of the presence of hydrogen bonding. Let's draw the graph. It goes like this, guys. Very high. Water has high. Water has high. Very high. Yeah. H2O high. Then we have H2S. We have H2SE. H2TE, like that. Why the water has high boiling point? Due to the presence of H bonding, hydrogen bonding. And lastly, we have to discuss the hydrides of group 7 elements. Look at the group 7 elements like HF, HCl. Same, they are highly soluble in water because of the hydrogen bonding. They have high boiling point because of hydrogen bonding. HF, HCl, HBr, HI. Same thing. HF has high boiling point due to the presence of hydrogen bonding. HCl has the boiling point increases from here. Very high, decrease, then increase. The reason why the boiling point increases from HCl to HI is due to the large size. Even though HF is a small size, but it has high boiling point. The reason behind is because of the presence of hydrogen bonding. You will get these kind of question in your examination, guys. Now, one more thing. When we compare ammonia, HF, and water, which of them has the highest boiling point? Let's see. Let's check all the three. The strongest bond is the strongest hydrogen bond undoubtedly is present in HF because of high electronegativity of the fluorine. Look at that. I'm giving you one question. Among HF comma H2O and ammonia and H3, which one has which one has highest boiling point? What's your guess, guys? HF? Okay. No doubt, the strongest hydrogen bond is present in HF. But the boiling point, when you compare to the boiling point, you can't say due to the presence of hydrogen bonding. All of them, they have hydrogen bonding. So which one has the highest boiling point? Most of the student HF, because of the strong boiling point. The answer is water molecule. Why the water molecule, sir? Water molecule has two hydrogen bond compared to HF and ammonia. Ammonia has one hydrogen bond, and HF also has one hydrogen bond. But when you compare water molecule, it has two hydrogen bonding. And because of the presence of hydrogen bond in water, it helps to make ice less denser so that ice floats on water. Mostly, guys, when you look at the solid state of any compound, it should be more denser. But here, ice is the solid form of water, which is less denser than water. That's why it floats on the surface of the water. And look at the reason behind why ice is less dense than the water. Let's see. Ice is less denser than water. That's why it floats on the surface of the water. Ice has hydrogen bonding. Look at the structure of the ice. It forms like a open structure, open lattice. It's called open lattice. Look at that. So we have H2O. This is H2O. We have oxygen here, hydrogen and a hydrogen, hydrogen and hydrogen, hydrogen here also, partial positive, and one more hydrogen, one more hydrogen, one more hydrogen, one more hydrogen. So water has total four bond, two covalent bond and two hydrogen bond. Look at that. So it has two hydrogen, two hydrogen. Each has two hydrogen. Look at that. Two hydrogen, two hydrogen. Partial positive, partial negative. Look at that. So we have slight negative charge. Oxygen is highly electronegative. Slight negative, 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 negative. Now look at the bond. Positive, 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 partial positive, partial positive, partial positive, partial positive, partial positive, partial positive, 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 partial positive, partial positive. Now, the hydrogen bond is present between highly electronegative atom like oxygen and hydrogen. So I told you two hydrogen bonds, one and one, because it has two hydrogen, one, 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 and it form a open lattice structure. This is called lattice structure of ice or open structure of water. It form a cage like structure, again two, again two, again two. So why there is a question, why the ice is less denser than water? The hydrogen bond present in the ice molecule make the water molecule apart. Why ice is less denser than water molecule? The presence of hydrogen bonds. How many? Two hydrogen bonds in ice make water molecule apart. That's why it's less denser. We have kind of some space in that which make the ice less denser than water molecule. Hydrogen bond is present in biological molecule also. Just I want to discuss briefly about biomolecule, only the DNA, because DNA has hydrogen bonding. Hydrogen bonding in biomolecule. Like DNA is a biomolecule. DNA, deoxyribose nucleic acid. We know that DNA has a double helical structure. Guys, I'm not teaching biology, but I'm showing you the presence of hydrogen bond in DNA. It has a double helical structure. The DNA has a double helical structure like this, and a DNA has some nitrogen bases, which is like, for example, A, T, C, G, adenosine, thymine, cytosine, glycine. So they are connected. So these two strands, single strand, are complementary to each other, and they make a bond with the help of hydrogen bonding. They make a perfect shape due to the presence of hydrogen bonding. So between A and T, there is two hydrogen bond, and between C and G, there is three hydrogen bond, which make the molecule perfectly helical structure. So it's called alpha helical. So uh, the bonding, the pair between A and T, it's because of the two hydrogen bond, and the pair between C and G is because of three hydrogen bonding. One more thing, the secondary structure of our protein molecule is also contain hydrogen bond, and some cellulose molecule, not some, my bad, cellulose molecule, which is a linear molecule. Look at the cellulose as a polysaccharide. It is a polymer of beta glucose, and it form a linear structure which is alpha coil, or which is a coil structure. That coiling is called alpha coiling because of right-handed coiling. Each linear structure bind to another linear structure with the help of a bond, which is nothing but a hydrogen bond, and that makes the molecule more strong. This is also called cross bridges. So in biomolecule DNA, the structure of the perfect structure of the DNA is because of the presence of hydrogen bonding. Uh, Secondary structure of the protein is due to the presence of the hydrogen bonding, and they also form some cross bridges. It has alpha helical and a beta pleated structure. Proteins, secondary structure of the protein. Secondary structure that has hydrogen bonding. Cellulose, which is a carbohydrate, cellulose is a polysaccharide, which is a polymer of beta glucose, and it is a linear molecule, not the branch like a starch and glycogen. And each linear structure is coiled further, and these two coil, they join together by means of the hydrogen bonding. So this is hydrogen bond, H bond. Here protein has hydrogen bond, and these are also hydrogen bond. Okay, so many importance of hydrogen bonding. First of all, due to the presence of the hydrogen bonding, it is highly soluble, and it has a more boiling point. Hydrogen bond is a weak electrostatic force of attraction between the two molecules. Okay, guys. Now I want to stop my video here, and in my next video, hopefully, I'm going to teach a permanent dipole interaction, And lastly, induced dipole and induced dipole. Thanks for watching my video.